response assignment. So let me get a pointy stick. Let me get my board pen and lights out and unfreeze. Nice. Okay. So when you log in, the reading is assigned. So the reading link will take you right here to this page. So you can scroll through and find different answers that you're looking for. We're going to go over the constructed response together first. And then when you get done with that, once you submit that, you can go ahead and do the multiple choice assignment that is also assigned. So we have two assignments today, the multiple choice one and the constructed response one. So constructed response first. We have only two questions with a couple miniature questions in between. So number one, sudden movements along fault lines release seismic waves that travel along the ground through the Earth's interior. That's an earthquake. So we're talking about the waves that are generated when an earthquake happens. So first part, identify and describe three types of seismic waves. Be sure to note how each of the waves differs from the other one. So we need to talk about the three different types of waves. Let's see if these markers work. Yeah, that'll work fine. So we have these three different waves. P waves, S waves, and surface waves. So the P waves and the S waves both are body waves. They move through the interior of the Earth. So P waves are body waves. S waves are body waves. Surface waves, as it says in the name, just move along the surface. The P waves are also going to be the fastest waves, and they are compressional. The S waves are they're not going to be the fastest or the slowest. They're going to be right in the middle, but they are shear waves. And then the surface waves are going to be the slowest waves. They will arrive last. As the name suggests, they only travel along the surface. And they're the ones that are going to do the most damage. So I'm going to change it on that. And so they travel the slowest, and they do the most damage. So that should be good enough. Identify and describe the three types of seismic waves. Be sure to note how each wave differs from the other. I think we did that. So P waves, S waves, surface waves. The P waves and the S waves are body waves, which means they travel through the inside of the Earth. The surface waves are obviously going to stay at the surface. The P waves are the fastest. They're compressional, which means they squeeze in and out as they travel a certain direction. The S waves are shear, which means they move left to right as they travel in the forward direction. And then your surface waves are the slowest, and they do the most damage. That should be good enough. Okay, now next part of the question. Explain how scientists can use data from body waves. So when they say body waves, they specifically mean the P and the S. To study the Earth's interior, be sure to identify at least two distinct body waves, the P and the S, and explain what scientists can infer about the Earth's interior by studying their motion. So the first thing that we kind of went through yesterday was that S waves only travel through liquids. No, sorry. That's the opposite. The S waves can't travel through liquids. And so for the first part, what can S waves tell us about the Earth's interior? If we watch where the S waves are going and we see parts of the Earth's interior that the S waves cannot travel through, then we know that part of the Earth is a liquid part. It's been melted enough where there's nothing solid. It's only molten rock in there. It's magma. And so For the S waves, we see where they go and where they don't go. If an S wave can't travel through a part of the Earth, we know that it's a liquid because S waves cannot travel through liquids. For the P waves can go through anything. They go through all of it, liquid, solid. P waves can travel through gas. P waves can go everywhere. So what can P waves tell us about the Earth's interior? For P waves, we look at the speed of the P waves. And so if the P waves speed up, we know that that area is more dense. If the P waves slow down, we know that that area is less dense, maybe like a liquid. And so we can see the density and sometimes what type of material is inside the Earth by seeing how the P waves travel through that. So those are your two things. Your S waves tell you whether it's a solid or a liquid, and they can also tell you about density. Your P waves will tell you primarily about density, how compact, how like dense a part of the Earth is. So that should be those first two. Now to question number 2. After a major earthquake, the news story reports the earthquake's epicenter and its magnitude on the Richter scale. So they tell us the epicenter and the magnitude. First, define epicenter. So we talked about this yesterday in the reading. If we come over here, did they tell us about this on the first page? Maybe. No, let's see. Okay, yes, so the epicenter, as we saw in this picture here, the epicenter is where the earthquake happens on a map. So it doesn't tell us about the depth, it just tells us about the location on the map where the earthquake was centered. So that should be the definition of an epicenter, the location on the map where the earthquake was centered. They say in the book here, the spot on the Earth's surface directly above the focus, that's where the earthquake happened. So next part, explain how scientists locate an earthquake's epicenter. So we talked about that yesterday. That's got to be your triangulation. So they need 3 seismometers. Seismometers is what we use to detect the earthquake. Just like a thermometer is what we use to detect temperature. It tells you the thermo or the heat of something. A seismometer is what records earthquake seismic waves. And so if we have 3 of those and we plot them on a map and it tells us how far away the earthquake is, we can triangulate the location of the epicenter. So you need data from 3 seismometers that recorded the earthquake to find out where the epicenter is on the map. Maybe write something about drawing the 3 circles around each seismometer, and where all 3 circles meet in one place, that's where the earthquake happened. So how do we locate the epicenter? We get information from 3 different seismometers. We draw 3 circles on the map around those seismometers, and where those 3 circles meet, there should only be one place where all 3 of the circles meet. That is where the earthquake happened. That was where the epicenter is. And then number 3, or the third part of this question, explain what magnitude measures and what it indicates about an earthquake's effect on nearby regions. Be sure to explain what the numbers of the Richter scale indicate about an earthquake. So if we come back here to the Richter scale, which I believe will be on the next page. Yes, quantifying the severity of earthquakes. They talk about the Richter scale right up front. The Richter scale is a logarithmic scale that provides information about the energy released during the earthquake. Hold on, each number increases the magnitude. Yes, so the Richter scale provides information about the energy released during an earthquake. So the Richter scale is based on the amount of energy released during an earthquake. Is that what they're asking? Explain what magnitude measures and what it indicates on the earthquake's effect. Be sure to explain what the numbers on the Richter scale indicate. So yes, Richter scale indicates the amount of energy released during an earthquake. Obviously, the more energy that's released during an earthquake, the more the shaking and the more the damage. The less energy, the less shaking, the less damage. And then for the Richter scale itself, the last thing they ask is, be sure to explain what the numbers on the Richter scale indicate about an earthquake. So I would just say the Richter scale is a scale from 1 to 10. So it goes from 1 up to 10. And for every step up in numbers, so like from 6 to 7, every single step up in numbers is 32 times more energy. So for every one step up on the Richter scale, the earthquake gets 32 times more powerful. And that should be it. That should be a good explanation for both of these. So, yes. Magnitude measures the amount of energy released in the earthquake. The amount of energy released in the earthquake. Anybody have any more questions when we go over anything on this one? Nice. So make sure when you get done with this one, hit submit. You want to get as many grades as you can and don't want to get zeros on easy assignments like this where I literally tell you all the answers. So type that stuff in. Know that I'm recording this, so if you want to come back and watch through this later, if you missed something, you could just tell me now and I'll just repeat it. But if you want to go back to the video will be posted online in just a little bit. And keep your reading page open because you should work through the multiple choice now. So the multiple choice is assigned. If you have any questions on the multiple choice, just let me know. But I think this one's pretty straightforward, and we covered everything yesterday, and it's all right there in the reading. So they ask you about seismic waves, what the seismic waves are doing, what they can do, what they can't do. Some of these answers we just wrote down right now, too. So just read through this. If you have any questions, let me know. Take your time on it. And, yeah. And for those of y'all that have emailed me about other assignments or grades that you've changed, I'm working on it. I'll let you know in just a minute. So that's what we're doing today. Do those two. And then tomorrow you will have a sub. And it will be a makeup day. So if you have any questions, let me know. And have a nice day.